Okay, so welcome to SCI210, SCI410. So this unit is a split level unit. So uh, people may be doing it as SCI210, which is an undergraduate unit, or they might be doing it as SCI410 as postgraduate or something like that. So the content of the unit is going to be exactly the same for both units. I'll get to the difference in a second. So I just want to sort of just go over the Moodle site a little bit at the beginning, just so you know what's there and how it will progress throughout the trimester. Okay, so this is a little bit of introduction to SCI210, 410. So this unit is, I guess you'd call it an introduction to programming from the perspective of science students. So you can do other introduction to programming units at UNE, say COSC 110 computer science. But this unit, it will cover similar programming concepts, but it will do it with different contexts. So we'll do it in the context of looking at some scientific applications and these sorts of things. So if you already know some programming, then the programming stuff may not be new, but you may get a new perspective on it. And if you don't know any programming, that's fine as well. We'll begin from the beginning. So the only real difference between SCI410 and SCI210 is in SCI410, students have a final project, which they can find out more information about that on Moodle, but pretty much the final project is open-ended. They get to choose a topic that interests them, and they have to find some data and a paper about that topic, do an analysis on that topic, and write a report on that. So that's pretty much the only difference. So the SCI410 have to demonstrate a higher level of mastery of the concept through this final project, but the concepts in the lecture material is the same for both units. So the lectures will be the same. So access to MATLAB is required. We're using the software MATLAB for this unit. So MATLAB is not free software. You can log in to Turing, which is a server at UNE, and use MATLAB remotely via that. However, it's probably easier for you to install MATLAB on your own computer. So as I said, MATLAB's not free, but as students of UNE, you're part of the UNE license. So if you're interested in installing MATLAB on your own computer as a UNE student, it's free for you. Send me an email. I can add you to the license, and then you'll get installation and download instructions, and I think that will last for a year for free. Okay, so that's a good thing. Okay, so these are some learning outcomes. So just familiarize yourself with that. So my name is Matt, so this is my email address. So for general questions, academic questions, questions about unit material assessment items, essentially anything that isn't of a personal nature, I would encourage you to post it on the Moodle forums. Okay, so the reason why I would encourage you, so there's a general discussion forum here. Okay, so let's just fix this up right now. I see. Okay, so there's an assessment forum as well. Okay, so there's a general discussion forum, there's an assessment forum. So if you've got a question that's not of a personal nature, post it there. The reason why I would encourage that is because oftentimes your peers can help you out faster than I can. And even if I help you out, which I'll do, other people can see the question and see the answer, right? So it's a lot less duplication of effort for me. And but of course, if you have a question that's of a personal nature, send me an email, and I'm happy to deal with that. So if you send me an email, I mean, I teach more than one unit this trimester, so it's good if you include your name and what unit you're studying in the email in the subject, so I actually know what you're talking about. If the question might be a little bit vague. Okay, so it's UNE policy that I reply to questions on Moodle, or so if someone posts a question on Moodle and another student has an adequate response, I may not reply at all. I consider that answered. But if there's something to add, or you send me an email, it's UNE policy that I answer within 3 working days. That doesn't include weekends. Now, most of the time I'll be answering faster than that, but just be aware that if there's an assignment due, you can't send me an email the day before and expect me to answer it beforehand, so you have to be organized. Try things out with enough time so you can ask questions and get responses with enough time, okay? You can't expect me to answer or read things on the weekend. Sometimes I will answer on the weekend, but you can't expect that from me. Okay. This is a textbook we'll be going through. The lecture material will follow this textbook fairly closely. This is the 4th edition. If you have an early edition like the 3rd edition, that's fine. The textbook doesn't change really that much. Okay, so we have the topics that we'll be following from week to week. So topic in week 1 is Introduction to MATLAB, which covers the first 2 chapters of the textbook. So we'll cover the introduction pretty quickly, get into it pretty fast, and I'll say more about this in a second. Excuse me. So the thing to note about this course is that there is an assessment every week. Okay, the assessment isn't going to be massive. Okay, but it's just there to keep you going through the unit, right? So you don't just cram 4 weeks of material in 1 week. This is going to the idea is to keep you going through the material. Submit something once a week. The assignments aren't going to be massive. The first one is fairly straightforward and easy. They will get more difficult than the first assignment, but again, it's not going to be a huge time burden each week, okay? So there is a practical every week, 4 to 5 p.m. in one of the computing labs. So on the original timetable that was in the room MCL1, note that has changed to MCL3, because it's just upstairs. So the idea behind that is that there'll be no more material presented in that thing. It's just an opportunity for you to come, work on your things and ask questions to me, get individual help on your programming or whatever. You can come and ask me questions about the assignments. So the practicals are on Mondays, the assignments are due on Wednesdays, so it gives you enough time to come and work through your assignments and ask questions before the assignment is due. I'd also encourage you to work through the exercises at the end of each chapter. This is a good opportunity for you to extend yourself, and feel free to come to the practicals, work through them, ask me questions. You can come to practicals and ask me questions about other things as well. It doesn't have to be about the assignments or about the exercises. It can be about something that you found difficult during the lecture. It's just an opportunity for you to have sort of a more one-on-one interaction with me rather than me sitting in front of you lecturing to you. Okay? That's the purpose of that hour. Okay. So there's a 2-hour block each week for the lecturing. Occasionally I might use the whole 2 hours, but often I won't go for the full 2 hours, but I'll usually go for more than 1 hour. So what I'll do is at the end of, I'll probably go for about 15 minutes, and then we'll have a 5-10 minute break, and then we'll continue on. And so usually it won't be for the whole 2 hours, but sometimes it will. Okay. So the unit, I mean, this isn't the first time this unit is running, but I'm reorganizing it a little bit this time. So all the material is not ready yet, so I'll be posting material as we go. So material for this week and next week is up. So that's the slides. So the slides for the week will be posted by the Sunday. Okay, so I've got the stuff up for next week already, but the stuff for week 3 will be posted by the Sunday just before the start of the week. And the assignment 1 will be posted just before week 1, so before week 1. So you have 1 week plus until the next Wednesday to work on. So you have 10 days pretty much to actually, 10 days pretty much to work on. Assignments for the first 2 weeks are there already. So assignments up until the ones that's due in week 3, because the first assignment is not due until next week, is up there already. So you can take a look at those. The final project, remember this is only for SCI210. This is the final project. This is the second assignment, and this is the first assignment. Okay, so there's the final exam for this unit. It's worth 50% of the unit. You must also pass the final exam to pass the unit. So to pass the unit, you must get at least 50% overall and at least 50% on the final exam. Okay? So for the assignments, each assignment, each work is worth 5%. That's for the SCI210 students. For the SCI410 students, the assignments each week are only worth 2%. Okay? So I expect the SCI410 students to be slightly more advanced. So the weekly assignments are only worth 2% for the SCI410 students. And then the remaining 30% for the SCI410 students are made up by the final project. Okay. So that again, if you're SCI210, you have weekly assignments, 10 of them worth 5% each, and a 50% final exam. If you're SCI410, you have weekly assessments worth 2% each, 30% final project, 50% final exam. Okay. Okay, so that's pretty much what I wanted to go over at the beginning. So let's get started. Okay, so I'll be going through slides each week, but I just won't be going through slides. I'll be demonstrating stuff in MATLAB as well. So actually, I won't be posting these lectures to Echo 360. They'll be going up on YouTube, and I'll be linking them to YouTube, so they'll still be recorded, but they won't be on Echo 360. The reason why I'm not on Echo 360, because Echo 360 handles slides quite well, but when there's a lot of motion happening, like me handling MATLAB, the compression destroys it and it becomes unreadable. Okay, so this will be going up on YouTube, just because Echo 360 doesn't work that well for when you're doing a lot of activity on the screen. Okay. So we're using MATLAB. Why MATLAB? MATLAB is an interactive environment. It's used quite a lot by scientists and engineers. And so you can use it for things like data analysis, so maybe some statistics, fitting lines, etc. Visualizing data, presenting data, like doing graphs, plots, things like that. Signal processing, image processing, okay, so filtering images and things like that. So developing programs and algorithms in MATLAB to do certain things. You can also use MATLAB and connect it up to scientific equipment. to acquire that data and log that data in a lab. Okay, so in the end, it doesn't particularly matter exactly what language we use. The skills we learn in this will be transferable to many other environments. So, for example, R is another common environment in scientific applications in terms of scientific data exploration and statistics. Python is also starting to become more and more common in this area. But the point is that so in this unit we learn how to use MATLAB for sure, but we also learn fundamental concepts, which is sort of independent of MATLAB and will help you in these other areas as well. So although we're using MATLAB in here, you should be able to take the skills you learn in this and apply it to things like Python or R or other programming environments. Okay, so what to expect in here, I've already sort of gone over this. So weekly topics will closely follow the textbook. So beginning in week 3, each topic will have a different scientific theme. The weekly lecture recordings will be quite long, so 1.5 hours to 2 hours. But you don't have to view the whole lecture in one sitting, of course. In the actual lecture, we'll take a break midway through so we can sort of regroup. So if you're following this at home, it's probably a good idea to have MATLAB open so you can work along with me. Whenever possible, pause the video, try it out yourself. There's lots of stuff on Moodle to help you. Okay, so there's one thing I'll say about attending lectures. If you can, of course, if you're off campus, you can't attend lectures, but if you're on campus, I'd still encourage you to attend the lectures in person. Okay, so in one sense, the recorded material is strictly better than me sitting here live. You can pause it, you can rewind it. That's not possible with me sitting here. So if you're super disciplined and you're going to sit down at a regular time each week and go through the lecture online, then it's probably better that you do that, okay? But the point is that most students or most people aren't super disciplined, and you think you're gonna sit down and watch the lecture each week, but then time comes for an exam and you have to spend 7 hours in a row catching up on lecture material, and that's not optimum. You get tired. You've got questions to ask, you have this whole list of questions to ask just before the exam. Perhaps I can't answer them all just before the exam. Okay, that's not an optimal way to learn. Okay, by coming to the lecture, at least you're seeing the material. Even in the worst case scenario, let's say in the worst case scenario you don't understand anything in the lecture, it's still not a waste of time. At least you know what you need to go away and look at, and you can come to the tutorial and ask me questions. So coming to the lecture is incredibly useful. And it's sort of like you have to cover the content in these 11 weeks some way. You can either do it, come every week for an hour and a half to 2 hours, do it that way, or you can choose to cram it all at once if you want to. But if it was me, I would choose the former. Okay? So as you tackle more complex tasks, you'll often have questions with MATLAB. MATLAB's got decent inbuilt help, and Google is often quite useful in finding out how to do things, okay? So, I mean, I'm here to help you, of course. I'm not just going to say Google it. If you have questions, ask me. But also, learning how to use Google and the inbuilt MATLAB help is important for learning new things, and sort of after this unit, if you do these things in the future, learning how to use those resources are important as well. So the MATLAB website, you go to mathworks.com, you have support and community. So support is help pages, community is like an online forum where you can find many questions. But of course, if you can't find stuff there, or you can just ask me first before you start looking at those things. Okay, so sorry that I've forgotten to update that. So there will be 10 weekly assignments We're not using MATLAB anymore, so just ignore that. There's a final exam. For SCI210, there will also be a final project. So that's the cover of the 3rd edition. As I said, doesn't really matter if you use the 3rd or the 4th edition. These textbook has many useful features. At the end of each chapter, there's a summary. So this would be good for reviewing, say. Programming style guidelines, indicating what's good style in your programs. There's 2 aspects of programming, right? You're giving instructions for the computer to follow, but you also have to understand them, and you're usually programming with other people or sharing your code with other people, and these other people have to understand them, or you might come back to something 1 year later and forgotten most of the contents, and you have to understand them again. There's certain guidelines in programming that we follow to make it easier for humans to understand. The computer, the computer won't care, but it's for humans to understand, right? And we'll cover some of these guidelines as we go throughout the course. And if you read the assignment criteria, the assignments will require you to follow good style, okay, when you submit your work. At the end of each chapter, there's a functions commands that have been covered. So these are good if you forget something and you don't know where it is in the textbook. Probably the index is a good place to start, but you can just look at these summaries at the end of the chapters to see if it's in that chapter or not. And there's lots of exercise at the end, okay? So programming is one of those things, like most things in life, you're going to get good at it by doing it. Do as many exercises as you can. I'm happy to help you, but the more you put in, the more you'll get out. Okay, so when you open up MATLAB, either on Turing or your local machine, it's going to look something like this, okay? So this is a command window. So I've got MATLAB open now. Mine looks a little bit different because the environment is highly configurable. But this is my command window. I can use it like a calculator. I can go 5 plus 10, okay? I can go sine of 3 and get a number, right? I can use it as a calculator. So that's your command window. This is your workspace, which I don't currently have open in my current window, but this workspace is useful. It lets you know what variables you currently have defined and the values within them. So let's come across here. I want to... Actually, I do have the workspace. My workspace is down there, though. Okay, so I do have the workspace open. This is the command history. This is the history of all the commands. I personally don't find it that useful, so I just closed that down in mine, but it's there if you want it. You have your current folder that you're looking at, so you can open up files and analyze them, etc. You can also have this little window down here which describes which of each of these files is, a little description based on the comments in the files. We'll get to that in a second. I tend to just have this closed, but you might have it open. Okay, so in the beginning we'll use the command window. So in this lecture we'll just use the command window to enter commands, and so that's sort of like using a calculator. If you want to do anything more complicated, it gets annoying because you have to repeat it over and over again. So that's the idea behind scripts. So a script is like a little programs. You write what commands you want in the program, then you get MATLAB to run them, and you can just do that over and over again, right? So you don't have to retype it every time. You have it saved in a file, it's a program, rerun it whenever you want. So we'll start doing scripts next week. Okay, as I said, the desktop environment, you can just use it as some sort of fancy calculator, right? You can enter stuff, you get answers. If you enter stuff like that, it's stored in the answer variable. So if I come back here, I see that this sine 3 has been stored in this variable, ants, and I got this variable. My workspace tells me that I have this variable ants. It tells me what its value is, okay? So variables and assignments. So Sometimes we want to store a value and reuse it later. So we do that with assigning variables. Okay, so let's say I've got 5 plus 10, and it's some important number for me. I don't want to keep on retyping it. It's some number x, and I want to use it later on. I can go x equals 5 plus 10. Okay, so it's important that you do it like in exactly this way. You have the variable name, you have equals, then you have the expression. Okay, then we see down in my workspace I have another variable defined now, x, and its value is 15. I could use its value later on. So instead of so I could go 2 times x. Okay, so in MATLAB, times is done by the asterisk. Gives me 30. So I can store variables and use them later. Okay. Note that this isn't equality in the mathematical sense. So for example, I could take 2x and put that in the x variable again. So I could go x is equal to 2 times x, and x is currently 15, right? Times it by 2 gives me 30, then store it in x. So x will be 30 at the end of this. But if I just took equals in the mathematical sense as an equation, this equation x equals 2x tells me that x is equal to 0, right? As a mathematical equation. So that's not what this equal sign means. This equal sign means whatever's on the right of it, store it in the variable on the left. Okay, so think of it like that. Okay, so we see that whenever we're going through this, we have the output down here. Perhaps that gets annoying after a while. Perhaps you want to define a new variable, which is like the sign of 1. And we don't care about what the exact output is right now. We put a semicolon at the end. That will suppress the output. The command is still executed. We see that we have a new y value. It's got a value in here, but it just suppresses this output. Okay? This is particularly useful when we start to do scripts. Scripts do lots of calculations, and if we run them without semicolons, we just get a whole lot of stuff dumped to the screen, which isn't necessarily interesting or useful, and it can detract away from the things that are useful. So we put semicolons at the end of our instructions, and we just display the things that we want to know instead of displaying everything in the calculation. Okay, but we'll cover that again next week. So variable names. Okay, so variable names, so this is what we call variables, like x, y. They must begin with a letter. Okay, A through Z. It can be lowercase or uppercase. After the first letter, or letters, you can contain letters, digits, 0 through 9, under underscore character, right? It can't contain any other character. It can't contain question marks. It can't contain commas. It can't contain spaces, okay? MATLAB is case sensitive. So what do I mean by that? If I go x is equal to 5, capital X is a new variable. It's different from little x. So if I go like that, I've got a new variable, capital X, it's 5, little x remains the same, okay? So be aware of this. This can be confusing. Names should make sense, okay? So typically I've done x, x, y. These aren't very descriptive names. When you're doing programming, your names should describe the values that's in them. This is part of the style thing I was talking about before. The computer doesn't care, but when you're reading your program later, or somebody else is reading your program later, it's going to be much easier to understand. Let's just say we're calculating the area of a rectangle, and the rectangle's got width equals 6, so I type width is equal to 6, and it's got height is equal to 10, and then I've got area is equal to width times height, right? and I don't put a semicolon here because I want to know the result. Okay? This is much, much clearer than if you said x equals 6, y equals 10, z equals x times y, right? It's much more understandable what you're doing. So variable names should describe what they are. There is a maximum length for your variable names. You can find this using the built-in function name length max. Typically, you don't need to worry about this. It's usually long enough, and you're not going to be writing variable names that long. So if I go name length max, 63 characters, right? You're typically not going to be writing variables that are names are that long. It's going to be a little bit arduous and annoying having to type in variable names that are 63 characters long, so it's not going to happen. Names should make sense, as I said. Meaningful variable names. Okay, so let's define a variable for the speed of light. Which is the most appropriate name? So which do you think is the most appropriate name here? Okay, anyone? Bottom one. Yeah, exactly, right? It tells you exactly what it means, speed of light, okay? There's no confusion there. Maybe in the context of a program, you might have a program that's talking about speeds, and so something like this may be okay, may be okay from the context. But something like this is always going to be okay. It's always clear what it means. Things like this, I just don't do it, okay? S. I mean, if you're a mathematician, sure. Just do it like this. Mathematicians work by hand. They don't want to handwrite things, so conciseness is important. We're on a computer, we can copy, paste things like that. Things get much easier. So make your variable names descriptive. Describe what they contain. Okay. Identifying and clearing variables. Do you have who, whose, clear, and CLF? So we haven't done figures yet, so just ignore this really for now. Okay, I have all my variables here that I've defined with their values. I can just also in the command window, I can type who. That will tell me all the variables that I've defined. If I go whose, that gives me more detailed information. Okay, it gives me all the variables and plus some other attributes of those variables, which we'll get to what they mean in a second. Okay, if I go clear, that clears all my variables. I've got no variables left. If I try to use x again, it doesn't know what I'm talking about. But x doesn't know what I'm talking about. Okay, doesn't know what I'm talking about. So if I go x equals 5, okay, let's just say I do width is equal to 5, height is equal to 10, area is equal to width times height. So if I go through it like this, so I have these variables I've got these variables defined. I don't have to clear with nothing else clears everything, right? I can clear individual things. So I can go clear area, for example, and that will just get rid of area. I still have width and height defined, right? Width is still there. Area is gone though, okay? So modifying variables. So we saw before that we can modify a variable after we create it. Remember, we defined x, and then we set x is equal to 2 times x. That uses the current value of x, times it by 2, then puts it into x. Okay? So things like this we can do. Okay, so variable types. So this is sort of, it's covered in the textbook. It's not entirely that. I'll still cover it in class, but it's not entirely important that important for this unit. Okay, so if you study programming in a computer science subject, they'll spend a lot more time talking about these things, variable types, because they're typically going to be using different types of things. But in MATLAB and in this unit, we're going to be mainly concerned with just numeric data, right? We're doing scientific applications, numeric data. So although this is interesting and somewhat important for the purposes of this course, it doesn't matter that much, okay? But I'll still cover it nonetheless. So we have different variable types. So we have numeric types. So these are types of variables that contain numbers. When I did back here, when I did whos, these are the variable types. Okay, so this is what those variables types were. Okay, so you have integers, can be signed, that is negative or positive. So if it's signed, it can be either negative or positive. Unsigned integers can only be positive. So we call it variable types. Another thing is the variable class. Class, that's those variables classes or types. Oops. Okay, another thing to note with MATLAB, which is really quite handy, many people don't know it when they're first getting started, is I can use the up and down arrows on my keyboard to go to previous instructions. Okay, so if I want to redo this with a slightly different thing, I don't have to retype the whole thing. Go up into my history using up, go to it, press across, just come here and change it to something else. Okay, so that's make your life a little bit easier. Okay, so back to this. So we have some signed integers. You have different types. They depend on the amount of memory they take up inside the computer. Okay, and they have a finite range. So they don't cover every possible integer because they only have a finite amount of space inside the computer. The higher ones that can store more memory have a larger range. Again, if you look at it here and then forget about it, it won't really matter. But maybe if you do some stuff later on, you can get some weird results that you won't understand unless you sort of have some idea of this. You have unsigned integers, they can't be negative, but because you're only restricting them to be positive, they don't have to worry about negative numbers, so they can store larger positive numbers, okay? Okay, we can have real numbers, which can be double or single precision. So these are the numbers that contain decimal points, so to speak. They're also the default numbers in MATLAB. When you enter a number into MATLAB, even if it's just 3, it's going to be storing it as a floating point number, as a real number by default. Okay, that's okay. We don't really care. The difference between single and double precision is the amount of memory they take. Single precision takes up 32 bits, double 64 bits. Again, the larger the amount of memory, the larger the range the values can store. Okay, by default, MATLAB stores all numeric values as a double. That's usually how we want to keep it, okay? If you're programming on a computer, say 40 years ago, the memory was very expensive. You didn't have much memory, okay? So these things mattered more then, okay? You wanted to make the most out of memory, so you had to be aware of how much things took up in memory, okay? So now, I mean, this laptop that I'm using has got, what, 8 gigabytes, which is 8 billion bytes. I don't really care if I'm using an extra, so 64 bits is, so this is what? This is 4 bytes, this is 8 bytes. If I've got 8 billion bytes, I don't really care if I'm using an extra 4 bytes here and there, right? It doesn't matter anymore, okay? It's an interesting thing to be aware of. For this unit, it won't matter that much. Characters. Okay, so this does matter a little bit, okay? So we have our numeric types. Think about numeric types as just doubles. We're just going to be using doubles there. We don't care about anything else, they're just doubles. But then we have character types, right? We're storing numbers, or we can store strings of letters, okay? These aren't numbers. So character strings are a sequence of characters enclosed in single quotes. So for example, I could say greeting. Okay, the thing to note is that you begin and end with a single quote. Okay? What happens if I want to put a single quote somewhere in the string? So for example, hi, I'm Matt. I am now using Matt's computer. Okay, something happens here because MATLAB thinks that the string's ended here because you have a single quote. And then it's this stuff here. It's like, well, what's that stuff there? It's going to get you an error. Okay? So if you want to use a single quote in a string, you put two single, not a double quote, but two single quotes together, and they'll give you a single quote in the string. Okay? So if I look down here, I've got this here. If I go who's, I see that the greeting, the class is not a double, it's characters. Okay? Okay, next thing is logical values. Represents true or false statements. And typically in MATLAB, these are represented using numbers. Okay, so 1 represents true, 0 represents false. Is 10 larger than pi? It is 1. Okay? Is 10 less than pi? It isn't. False. Okay? 1, 0 represent true and false in MATLAB. If you're used to another language like Python, this is not the case. They have their own true, false values, but in MATLAB, 1 is true, 0 is false. Okay, expressions can contain operators. So we have values like 5, 10. We have variables like x, y, width, area, variables that we name. Built-in functions, we've seen an example of this. We use sine, which is a built-in function to MATLAB. You have many other built-in functions like cos 10. Cos is a built-in function. You can use tan. Okay, these built-in functions. Okay, you can group things by parentheses. Multiplication is the asterisk. Division is your forward slash. Exponentiation is the caret symbol, which is shift 6. And E is that allows you to put things in scientific notation. So, and things behave with respect to parentheses as they do in normal mathematical notation. Okay, so for example, if I go 3 plus 5 times 10, it's going to do the 5 times 10 first. Multiplication becomes first, right? Remember from school, I remember it as, what do I remember it as? BODMAS, right? So brackets first, parentheses, or BOMDAS. Orders, so powers then, things up in exponentiation, multiplication, division, addition, and subtraction, okay? But what happens if we wanted to, so that multiplication is going to happen first. What happens if we want the addition to happen first? Well, we put it in brackets, right? Okay, so things follow normal mathematical rules. So if I go 3e2, this is scientific notation. This is 3 times 10 to the power of 2, 300. E in this case is not the mathematical number Euler's constant, right? So if I go E, this isn't defined. If I go pi, it's defined, but E isn't defined. If you want to get Euler's number, that's exponential to the power of 1. That will give you the Euler's number. Okay? So we'll take a break now for 5-10 minutes. We'll meet back here in 3 and I'll continue. Okay, so one thing you might notice is that MATLAB's only displaying sort of 5 significant figures here. You might think it's only calculating this. I mean, that would be quite rough. It's actually calculating with much more. So 64-bit floating point numbers have approximately 16 significant, 15.8 approximately, because the actually underlying is in binary, not decimal, so you don't have the exact 16 significant decimal figures, but there's more often 15 significant decimal figures. So if you wanted to, you could type into MATLAB format long, and that tells MATLAB, well, I want everything that you have. So if I go x1, gives me everything. Okay. So underlying, even if you don't type format long, all of MATLAB's underlying calculations are still going to be using as much precision as possible. You don't get any less precision by not doing that, but format long just displays more decimals. Okay, so this is what I just said before. You have your precedence of operators from mathematics. You should have covered that in school. So you have parentheses first. You do what's inside the parentheses first. Exponentiation next, so you do 3 to the power of 3 before you multiply. So this result is actually incorrect, right? I mean, what should this actually be? Three cubed, right, is what? 3,927. Times it by 2 should be 54, not 18. So that's actually a typo. Let's just check that in MATLAB. 2 times 3 to the power of 3, 54. That's 3 to the power of 3. 3 times 3 times 3, 927 times 2, 54. Okay, if you negate something, so for example, if I got x is equal to 10, and I look at negative x, it's going to be negative 10. That's done next. Then your multiplication division. Ignore forward slash for now. Don't use it. It can be confusing. No, sorry. That's the one you want to use. Sorry. Ignore backslash now for division. Okay. No, so it's okay. So I can go 5 divided by 3 to give me 1 point, or I can go 3 like that. It just swaps the arguments around, and I mean, it's sort of obvious what it does, but if you're quickly reading through a program, it can be a little bit confusing to change the context in your mind of where the numerator is and where the divisor is. So here the numerator is here, divisor here, here the numerator is here, and the divisor. So it can be confusing. So I would suggest not to use backslash, always use the forward slash operator for division. Then we have the addition and subtraction goes next. Okay, so let's have a think about what's going to happen here. So what do you think is going to happen when we enter 1 divided by 10? What do you think the result will be? Anybody? 0.1? Okay, let's try it. 0.1. Yeah, pretty obvious. What about this next one? 10 to the power of 4 divided by 2. 5,000. Yeah. What about this one here? What's 4 divided by 2? 2. 10 to the power of 2 is 100. Okay, so this is just practicing sort of the order of operations. Okay, here I do the power first, right? Then I negate. So it's going to be minus 36. Okay, if it was the negative first, it'd be minus 6 squared, which is positive 36. But the powers come first. This is what I'm doing here. I'm forcing the minus first by putting it in brackets. Then I'm squaring it, gives me 36. Okay. Let's have a think about a practice problem. Okay. So the molecular weight of carbon dioxide, which is your carbon atom with 2 oxygen atoms, is the sum of the atomic mass of 1 carbon atom and 2 oxygen atoms, obviously. Create variables to store the atomic mass of carbon, which is 12.011, and oxygen 15.99. So the atomic mass of carbon, 12.011. Okay, so what do you think? So I could go 12.011, right? Not a great variable name, though, right? So let's say I could go atomic mass carbon. That's probably a little long, a little unnecessary, but maybe just mass carbon. C for carbon, maybe, okay, maybe let's be more specific. 12.011. Okay, then I have oxygen, 5.999, mass oxygen. Okay, correct. Okay, so I don't have to type the whole thing again. Remember, I can just press up, go to the previous instruction, and just come across and edit it. Okay, saves me a few seconds. Note that the numbers that MATLAB puts in isn't exactly the numbers that we entered, right? They're a little bit off. And that's because underneath, MATLAB doesn't store numbers. I mean, we as humans work with decimal, right? We find it easier to work with decimal. But computers don't work with decimal, they work with binary. And the thing is that, so for example, in decimal, we know that there are numbers that can't be represented using finitely many decimal digits, right? If you go 1 divided by 3, you need 0.333333. You can't have a finite number of things. And the same thing is in binary. And it's different. So, for example, I can have a number that can be represented in decimal in finite number of digits, but take an infinite number of binary digits to represent. So for example, 0.1, finite number of decimal digits. But to represent it in binary, I need infinitely many digits. And so what's happening here is 15.999 can be represented in decimal exactly with using 5 digits, but in binary it can't. So when I enter that into the computer, it has to change it slightly to the nearest binary number that it can using finite. So essentially, it converts that to binary. I have infinitely many digits, right? It can't store infinitely many digits, so it's going to round it off at some point, and that rounding is what causes a slight deviation, okay? So it's something to be aware of. When you're usually doing arithmetic on a computer, it's not going to be mathematically exact. There's going to be errors. When you're doing lots of computation, the errors are going to accumulate, right? So one operation, okay, not much error. Do operations again and again and again in a large program. Errors can accumulate in bad ways. Okay, so we won't sort of look into it here, but this is a whole different topic on its own. Sort of if you do a course like AMath 250, you'll think about these things in a little bit more detail. But it's just something to be aware of. You aren't going to get exact mathematically correct results from the computer. You can using other packages, but in MATLAB and these sort of things you're not going to, okay? And typically in 99% of the cases, the rounding errors are small enough that the results are still valid, and that's all we really care about. But it's important just to keep in the back of your mind that things can go a little bit wrong sometimes. Okay, so use the variables above to calculate the molecular weight of carbon dioxide. Okay, so let's do that. So I got mass carbon dioxide, which is what? It's going to be 1 carbon and 2 oxygen, right? Mass carbon plus 2 times mass oxygen. Okay, that's the atomic mass of carbon dioxide. Use appropriate variable names. In the short term of things, it would have been easier, less typing for me if I just said x is equal to this, y is equal to this, z is equal to this times this. But most of the time when you're doing programming, you aren't going to be writing things that you're going to throw away. You're going to be writing things that you're going to be using again and again and again, or you might be writing things that are sharing with other people. Say if you're writing a program for your lab, you might not be the only one in the lab who's using the program, somebody else might be. And so it's important to use descriptive variable names so that in the long run it makes life a lot easier. Okay, so another thing to note is also, and this will become obvious as you continue through this unit, programming can be frustrating at times, very frustrating. Okay, so when we're speaking to each other in English or whatever your native language is, like human languages, people can make mistakes and the other person still understands, right? As long as the mistakes aren't massive. I can make grammatical errors in what I say, but you still understand what I mean, okay? The computer is not like this, or at least the programming languages that we have today aren't like this. Maybe it'll be different in 100 years, but what we have today is not like this. The computer does exactly what you say, it doesn't do what you mean, okay? You might mean one thing, type another thing, it's going to do what you type, not what you mean. If you have a grammatical error in what you type, or in programming, we call it a syntax error, the computer is not going to try to guess what you mean. It's going to say, I don't understand, there's an error. So it can be very frustrating at the start. You can have very small errors here and there, and the computer just says, no, I'm not going to do it, okay? And that can be frustrating, but you have to get used to the fact that the computer is sort of dumb. It does what you tell it to do very, very fast, but it's not very smart in interpreting what you want. Okay, so you have to tell it exactly what to do. And still, even with care, you're still going to make some mistakes from time to time. I mean, I've been programming for a long time, and I still make mistakes frequently. And as we go through the course, we'll see how you can deal and fix these errors. Okay. So in the previous example, we calculated the molecular mass of carbon dioxide. This value was stored as a double variable, which is MATLAB's default variable type. If the molecular mass is converted from a double to an int8 variable, what is the new value for the molecular mass? So remember, I've got carbon dioxide, mass carbon dioxide here. Okay, so if I force this number to be an integer, what do you think its value will be? What do you think it will do? Exactly, it's just going to force it to the sort of the nearest integer. Well, pretty much. Okay, so I've got some practice problems in here around these types. Typically, nobody cares in MATLAB about these types, okay? Mount Erebus is an active volcano on Ross Island, Antarctica, with average temperatures of -4 degrees Fahrenheit in the summer and -58 degrees Fahrenheit in the winter. Create a variable, ftemp, to store the average summer temperature, -4, okay? So this is another interesting thing about programming. And of course, there are more sophisticated ways around it, but the way most people program is MATLAB doesn't store units. Okay, Fahrenheit, Celsius, pounds, kilograms, okay, it doesn't store units. And so you have to be very careful, and it's not going to check it for you. You've got to be very careful when you're dealing with things in different units. You have to convert things to the correct units. And there's been very famous examples that cost lots of money because of errors in this case. So, one of NASA's Mars rovers totally missed, and they lost, I don't know, I guess it might have been billions of dollars worth of equipment because one team was working in imperial units, pounds, the other team was working in SI units, meters, kilograms, and they forgot to convert when they were combining the calculations, and they lost billions of dollars. So even experienced programmers make these errors, okay? So, but something to be aware of. Or there's been cases where, say, medical equipment used for what's the term? Radiological treatment of cancer, where they actually, radiation treatment of cancer. They have machines that fire very precise beams in the tumors of radiation to kill the tumor. There's been cases where bugs made in the software that handle those devices have been wrong. And there was a famous case where this machine was giving people like 10 or 20 times the dose, and 2 people died from it, and other people got really sick from it. And so when you're dealing with these types of things, you have to be very, very, very careful. Okay, but don't worry, you can make mistakes in this unit and nobody's gonna die. So yeah. Okay, so what we want to do is we now want to convert this value to Celsius and store the result in a new variable called CTemp. Note that the relationship between Celsius and Fahrenheit is this formula here. Celsius is equal to the Fahrenheit minus 32 times 5 divided by 9. Okay, so let's go CTemp. Ftemp, I forget, 32, 5 divided by 9. Minus 20 degrees. It's minus 4 degrees Celsius, Fahrenheit is minus 20 degrees Celsius. Okay. Reassign Ftemp to the average window temperature is minus 58 degrees and convert this temperature to Celsius. Okay, so I could retype it all, but I'm lazy, so I'm not. So again, my memory's not so great. So minus 58. And then I could retype it, but I don't have to. I can just go up here. Ftemp's a new value, so it's going to give me a new value of Ctemp, minus 50 degrees Celsius. Okay. Okay. So let's now talk about inbuilt functions. So to use a function, you call it. Okay. So you give its name followed by arguments that are passed to it in parentheses. So we've seen some examples. Okay. So in English, I would say I'm calling sign and I'm passing it its parameters 3, okay? We put the parameters in round parentheses. Absolute value, right? Remember, absolute value just gives you the magnitude of the number without the sign. So absolute value of a positive, so absolute value of 5 is 5, absolute value of 10 is 10, but absolute value of, say, minus pi is pi, right? Just get rid of the sign. Okay, so you call it by giving the name of the function, an argument, and it calculates the result. Of course, you could store the result in a variable, so I could go my number is equal to abs minus 3, for example. Okay. So as you see, this is a typical way of writing variable names. This is called what's called camel case. I mean, you don't have to use it. Camel because these look like camel humps. So you write your words, and for a new word, you put a capital letter. So that's how, because remember, with variable names, you can't have spaces. Another common style is maybe, so spaces, you use an underscore to separate. So it's just clearer what the variable is saying. Now, I'm not going to be prescriptive with what style you use, as long as it's readable and consistent. Okay, so I don't want to see this style and this style used in the same program, or I don't want to see a mix of styles used in the same program. I want consistency, but any style that's readable is fine. Okay, help functions. The help function can be used to identify MATLAB functions and learn how to use them. Okay, so for example, if I'm a little bit unsure about ABS, apps, I can go help apps. Brings up an explanation. What this is useful for is if you're reading somebody else's program and you come across some function that you don't really know what it's doing, okay, you just type help, bang, tells you what it is. I can also go doc apps, and that'll bring up MATLAB's inbuilt help, which is really quite comprehensive and good, and tells me the syntax, how to use it, what it gives me, some examples of using it. Okay. MATLAB's inbuilt help is actually really, really good. If you want to learn about something, for example, plotting, graph plotting and customization. So read about it. Maybe this is not what you want, but maybe you can see also something more relevant for you. Plotting. This function plots graph nodes and edges, gives you some different syntaxes, what each syntax does. What's really useful is the actual examples. So you can just look at the examples, see something approximating what you want, copy and paste the code, and just modify it to be exactly what you want. Right? That's pretty much what a lot of people do. Okay, so MATLAB's built-in help is really, really, really good, but it can be a little bit of a skill to use, just like using Google. It's a little bit of a skill to know what to search for. So in the beginning, it can be hard to find what you're really looking for, and in that case, feel free to ask me a question by email or by the forum, and I'm more than happy to help you out. Okay, so expressions can also contain built-in functions. So you can, I can go 5 times sine 10. I can put stuff in here. I can do all sorts of things, right? There's no real limit to what you do, right? So this is the exponential function of 1 plus 10. Take the sine of this times it by 5, okay? You can use these built-in functions in your expressions. One thing to note is the inbuilt trigonometric functions in MATLAB all work in radians, not degrees, okay? So that's an important thing. Remember, there's 2 pi radians for 360 degrees. So if you're working in degrees, convert your stuff to radians first. How do you convert degrees to radians? You times by pi, divide by 180, okay? Rounding and remainder functions. So you have fix, floor, ceil, and round. Okay, so let's have a look at these. So help. So let's say you come across this in somebody else's code, you don't know what they mean. Let's help fix, okay? Rounds towards 0. Okay, so if I go fix 5.1, 5. If I go 5.99, the nearest integer is 6, but it rounds towards 0. So go down to 5. Remember that minus 6.5 is on, if you imagine the number line with 0 in the middle, minus 6.5 is on the left. Rounding towards 0, it's going to go to minus 6. Okay, that's what fix does. Floor rounds towards minus infinity. So if you imagine the number line, it goes towards the left always. Okay, so if I go floor 5.9 again, it's going to go down towards 5. But if I go floor minus 6.9, it's going to go to the left, so it's going to go to minus 7. Okay? Ceiling, the other way around. Round, it will round to the nearest. Okay, so if I go round 5.1, it goes to 5, but if I go round 5.9, it'll go to 6. Okay, if I go around minus 6.9, it should go to minus 7, it should go to minus 6. Okay? Rem returns the remainder from a division. So let's look at exactly what this means. So this is your first example of a function that takes 2 parameters. Okay? So if I want to say, what's the remainder when I divide 5 by 3? The remainder should be 2, right? Yeah? Okay, so when you have more than one argument, this is like before you put the parameters or arguments in parentheses and you separate them by commas. Okay? Sign returns the sign of the number, so if the number is positive, it will return 1. If the number is negative, it will return negative 1. If the number is exactly 0, it will return 0. Okay? Okay, so practice problem, use the help function to learn about the fixed command, so we just did that. Using the help function, determine if the following pairs are equivalent. Use the command prompt to verify your expectations. So we've already used the help function. So let's just think about these things. Remember, fix rounds numbers towards 0. Floor rounds numbers to the left. Okay, so is fix 4.2 and floor 4.2 the same thing? Yeah. For positive numbers, they do the same thing. For negative numbers, they don't do the same thing, right? But for positive numbers, they do the same thing. Okay? Because if you're positive, rounding towards 0 is the same as rounding to the left. If you're negative, rounding towards 0 is the same as rounding to the right. Okay. What about fix 3.2 and fix minus 3.2? Are these the same thing? The thing to notice is that these are two very different numbers, right? So rounding this is going to give you 3, rounding this is going to give you minus 3, so they're definitely not the same. What about fix minus 3.7 and floor minus 3.7? No, that's exactly what we were saying before, right? So fix and floor are the same for positive numbers, but for negative numbers, they're not. Fix minus 3.7 will round towards 0, so it'll be minus 3. Floor minus 3.7, it's going to give you minus 4. Okay? What about fix minus 3.7 and ceiling minus 3.7? Are those the same thing? Remember, you fix minus 3.7 round towards the origin, 0, and ceiling rounds to the right. So they're both going to give me the same thing. Okay. Fantastic. Okay, so there are many inbuilt functions in MATLAB. Okay, most common mathematical functions are already in MATLAB. Your logarithms. Okay, so just log by itself is log to the natural base, base e. But if you want log base 2, you can go log 2. If you want log base 10, you can go log 10. X returns e to the power of x, where e is Euler's constant, 2.718 or whatever it is. There is no built-in constant for e. Remember, typing e by itself, you're talking about exponential notation. Use x instead. Do not confuse this with exponential notation, right? Be careful. There are many other built-in functions. So for example, square root, we'll take the square root. Nth root, an arbitrary root. Let's think about how this would work. This would have to take more than one argument, right? We'd have to take the number and the root that you want to take. Abs, that calculates the absolute value. So for example, I can go square root of 2, okay, 1.41. Let's have a look at how nth root works. Returns the nth root of real numbers. Nth root xn returns the real nth root, so that's the nth root of x. So let's go nth root. So I'm going to get 2. Square root is the same as the second root, right? So this would give me the same thing. It does. But I could also go the 6th root of 2, which would be this. Okay? Okay, so variables we've seen, we use them to store values that could change or are not known in advance. Constants are used, Constants are used when the value is known and cannot change. For example, pi is a mathematical constant, right? It means one thing definitely. I have pi here, okay? I is the square root of -1, it's the imaginary number. MATLAB has built-in facilities for complex numbers. J is another thing you can use for complex numbers. We're not going to really bother with this in this unit, but MATLAB's got inbuilt facility for dealing with complex numbers. Inf means infinity. NaN stands for not a number. Okay, what happens if you do something like 0 divided by 0? Doesn't really mathematically make sense. It's going to give you not a number. Okay, if you go exponential of some very large number, okay, remember MATLAB, as I was saying before when we were talking about types, the variables only have a fixed amount of memory they can handle, right? So anything that's extremely big, they won't be able to represent, so they're just going to say it's infinity. Okay? So it's not really infinity, right? It's actually a number, but it's too big for MATLAB to represent in 64 bits. Okay? A thing to be aware of. If you're dealing with a program where the numbers can get very large, then weird things can start to happen. But again, the range that MATLAB can represent is very big, and usually this is not a problem, right? Usually you don't have to think about it. Okay, MATLAB lets you do very bad things, okay? MATLAB will let you say, so I've got pi, okay, that's fine. MATLAB will let you do this, okay, very bad. So if you did this somewhere, then you forgot that you did it, and then you're doing like, what's the area of a circle of radius 2 pi r squared? It's going to give you completely the wrong answer. It's going to be pi is equal to 5. Okay? Sine is a built-in function. I can set sine is equal to 10. Then if I try to use it, it gives me weird things because it thinks it's not sine anymore. It's 10. Okay? So be careful of this, okay? If you think that the variable name you're using is probably built in, so for example, if you're using a variable name that you've seen before in mathematics, it's probably already built into MATLAB and you probably shouldn't be using it as a variable name. Okay? So if I go clears it all, and pi goes back to normal. Okay? But thing to be aware of, MATLAB will let you do these bad things and it won't complain, and you can get weird results and you don't know that they're wrong because MATLAB hasn't complained. Okay, let's have a look at this. Square root of 57, so we can go square root of 57. We could go nth root 57 second root. Okay, 4 to the power of 7, tan of pi. So what should tan of pi be? Okay, you think about the circle, pi goes around to the negative x-axis, tan gives you the slope, so that should be 0. It doesn't give you 0. It gives you a very, very small number though. Okay? Again, can't expect mathematically exact results from MATLAB or from most computer systems. Okay? This is a very small number. It's very close to 0. It's minus 1.2 times 10 to the minus 16, so it's a very small number. It's pretty close to 0, but it's not exactly 0, so be aware of these things.
If you turned off format long, that would just display 0.
Let's try it. So format short goes back to the previous thing, just to let you know. So scientists often expect their models with simulated data. This usually requires the use of random numbers. Okay, so for example, let's say you're a statistician and you come up with some model and some test of that model, and you want to see how that model behaves. Generally, you simulate random data according to some distribution to test your your stuff out. It's not real world data, it's not going to be, but it allows you to test your stuff out. Okay, so we can generate random numbers in MATLAB. So if I go rand, generates uniformly distributed random real numbers in the open interval 0 to 1. Okay, so if I go rand, okay, always going to be between 0 and 1. Each time I call it, it's going to be something different. And by uniformly distributed, I mean sort of in some vague, I mean this isn't exactly mathematically correct, but in some vague sense, each point is equally likely, right? So, so if you looked at the probability distribution function, that'd be 0, that would be 1, and that would be flat, right? Each number in 0 and 1 is equally likely to be distributed. One thing to note is that these numbers aren't truly random, right? They're actually generated in a non-random way. They're actually generated by a deterministic algorithm. But the algorithm is designed in such a way that most of the statistical properties of the numbers obey what you would expect from random numbers, but you can still get weird things happening, right? So for this unit, that will be enough. If you're interested, you can go random.org and you can download truly random numbers, right? Random numbers that are sort of taken from nature, like looking at, I'm not exactly sure how they do it here, but it'll explain it. So if you're aware of some quantum physics, there's this famous experiment, it's called the Stern-Gerlach experiment, demonstration of quantum mechanics, where you fire an electron between two magnetic plates, and the electron either goes up or down, depending on the electron's intrinsic spin, whether it's spinning left or right, roughly. And so you can't predict where it's going to go. Half the electrons go up, half the electrons go down. You can't predict it at all. It's sort of random. You can actually buy these machines that do thousands of Stern-Gerlach experiments per second and gives you random numbers. It gives you a 1 if the electron went up, gives you a -1 if the electron goes down. It's a pretty cool device. But for our purposes, these, what they call pseudo-random numbers will be enough. Not really random, but they behave random enough for our liking.
Can you restrict them?
Restrict them?
How random they are?
Yeah, I mean, so in some sense, they're not random at all, right? But there are different algorithms that give better results than others. But all the algorithms can be broken in some way. I mean, you can always come up with some examples that really show that the random numbers are really not random. But for the more sophisticated algorithms, you have to work really, really hard to do so. And so for most applications, it's going to be fine. But yeah, if you're interested in looking at pseudo-random numbers, there's plenty of examples online. Wikipedia page is pretty good on it. But just be aware that these aren't truly random numbers. Okay, I can generate random integers. So if I go rand I for integer, 9. So this is will give me an integer between 0 and 9. Each integer is got an equal chance of being generated. Okay?
And is that 0 and 9 inclusive, or does it exclude either?
Good question. I'm not sure. So let's go help rand I. Okay. Pseudo-random integers from a uniform discrete distribution. Okay, so I'm just interested in the initial case. So no, it's only from 1 up to that value. So in this case, it will be 1 up to 9 inclusive. So this number here is inclusive, but it will never generate 0. So it will be clear if the slide said from 1 to 9 inclusive of both endpoints. Okay? Won't include 0, but it could include 9. So for example, if I did rand I3, I did this a few times, I'll get 3 sometimes, right? I'll never get 0 though. Yeah. Okay, what happens if I want a different range? So I mean, I can go 1 to 20, 1 to 100, but what if I wanted 20 to 60? I could go rand I20 to 60. So MATLAB's got some weird notation sometimes. And this will become clearer later, but now you just accept it as gospel, and this is what you have to enter for MATLAB to make sense of it. You put the range in square brackets. Okay, so I'm pretty sure this will be inclusive of both endpoints now. So if I go 22, 22 can be generated. Hopefully 20 will be generated. Yeah, so it's inclusive of both endpoints.
More numbers, not just one number.
Okay, so we will get to that, but let's just do that quickly. Let's go. Okay, so what we're looking for is something like that, and is returns an n by n matrix. Okay, so if I wanted a 3 by 3 matrix with values like that, I could go, okay, 3 by 3 matrix, each value is random. If I just wanted just a single list, then that's like a matrix, say, with 1 row but 10 columns. Okay. So that's how we can generate random numbers. Well, pseudo-random numbers, as we would call them. Not truly random numbers, but for our purposes, it's fine. Sort of, you might be feeling sort of, this is a little bit boring at this stage, maybe, or maybe you find it interesting, but sort of, we're sort of going through, and maybe sort of, I guess what I want to say is that the content of the lectures will somewhat change after the first couple of weeks. The first couple of weeks is sort of just like learning a lot of different functions and learning about the basics of MATLAB. After you've got those foundations down, then we can start doing some more interesting things, right? So, but the first couple of weeks will be sort of like this, sort of just going through all the basic things, but then we can actually start doing some more interesting things. So if you're feeling a little bit bored now, then hopefully you won't be bored later. Okay. So, okay, what about, okay, so we're talking about uniformly distributed random variables between 0 and 1 before. What about normally distributed real numbers? Okay, so you go rand and n on the end. And it'll give you a standard, it'll give you a number that's distributed by the normal distribution, by the standard normal distribution. So the standard normal distribution is the one that's got mean 0, standard deviation 1. So if I go rand n, okay. Note that in MATLAB, if a function is valid without 0 parameters, I don't have to put parentheses there. So this is different from, say, a programming language like Python, where you'd always have to put parentheses at the end of a function call. So I've got random n. Every time I call it, gives me something different. Randomly distributed, normally distributed random number from the standard normal distribution. I could do something like, if I wanted 100 of them in a row, I could want 1 row, 100 columns. Give me all those, right? Okay, so I can generate lots of them at a time. If I really wanted to, I could generate 1e6, which is a million. I might display them, but it generates that like that, right? A million random variables like that. So it's pretty fast. Okay, so if you wanted to use a different standard deviation and mean, you can shift it like this. So you times it by the standard deviation plus the mean. So if you're a mathematician, this is fine, but maybe these are not great variable names, right? So let's go mean equals 100, standard deviation, say, of 5, and then I could go mean plus standard deviation times by rand n, and that would give me a normally distributed random number, normally distributed from the normal distribution with mean 100 and standard deviation of 5. Okay, so I can call it over and over again to get different random numbers from that. Okay, so I can generate a lot of these, and I can do a histogram of them. So that's going to give me sort of a count of approximately so MATLAB will automatically divide up into bins and count how many random variables are in each of these little intervals. And so for example, let's go random numbers, random n. So I want 1 million of them so that's 1 row, 1 million columns. Okay, so I don't want to MATLAB display it there also, I put a semicolon at the end. And I go histogram, hist, random numbers, and MATLAB will create a histogram for me. So the histogram isn't that great. Why isn't the histogram great? It's not recommended. Use histogram. Okay, so what happens if I use okay. So anyway, you sort of see the shape of the distribution, right, that is generating. For example, if I did the same thing, but with just the uniformly distributed between 0 and 1, and I looked at the histogram of that, that would be, so it's sort of like, it's between 0 and 1. Outside there's no values, and sort of each region has got equally chance. I mean, the reason why it's a little bit jagged is because we're using actual random numbers, right? So it's not going to be perfectly flat. The more values we use, so for example, if we say used 10 million values instead, it will be flatter, less jagged, but you get the idea. Okay, so what I'll do is I'll finish here for the day. I didn't quite make it through all the slides for this week, but that's probably because I did a little bit of Moodle at the start. It just won't go for 2 hours, so we'll be able to catch up. So we'll continue doing this next Thursday, and we will continue on with slides for week.